artificial intelligence, digital twins, machine learning, SCADA, there are terms that you cannot even count on fingers today. Welcome to Inner Circle by Autocar Professional, powered by PTC. This is managing digital transformation in the evolving tech era.
And yes, it has been evolving. This is Mukul and I am Mugdha Mishra, and we have an esteemed panel of guests here to talk on this topic. All the terms that Mukul just said, they were far away from auto world, but now they are intrinsic part of the auto world. Let's take this conversation forward. I have with me Mr. Ajay Dhiwan, OPG Mobility, then Mr. Mohal Lal Bhai from Mactor India, founder and CEO, and Dhirendra Kulkarni, Senior Director, PTC.
Also joining us is Mr. Gaurav Tanak, who is with Euler Motors, Mr. Ajay Mittal from Volvo Asia Commercial Vehicles, and Sandeep Raina for Maruti Suzuki. Gentlemen, let's open the house with the first question, a very general one. Starting with Sandeep, sir, you. 5 years back, digital transformation. Forget digital transformation, even the infotainment clusters were very basic. Today, they can do almost anything and everything. So if you were to trace the journey of digital transformation starting from 5 years back, today, and how that would look in 10 years from today, what would you say?
As far as this question that how we see the digital transformation happening, I think what is important is all the philosophy of this transformation is not for the sake of digital transformation. It is finally the end customer for whom the development or any concept is getting developed. So what we see digitization happening 5 years before, or what it's today and how things will transform, it will be primarily driven out of what we are finally offering to the end customer. So if we see typically the architectures, what we had and what we still today have it, but what we see that say in a traditional architecture where we had many ECUs in the vehicle, and each ECU was actually working in a silo, and there was a lot of effort being done by the engineers to make them communicate to each other so that the basic functioning of the vehicles can be taken care of. However, as things are evolving, as we see customers being more demanding, as we see how things are changing globally, and as we see how the regulations are getting mandated in this country, so with all that and how we see future requirements coming, I think, as you said, how things will happen, say changed, say 5 years down the line, because typically in a development cycle today, whatever is getting developed, that we'll be seeing on the roads, say next 4 to 5 years. So we see things getting more integrated, as we see that how the ECUs are coming together, how we have a compute power which is becoming more powerful in the machine, in the vehicle, as the kind of processing what needs to be done in the vehicle has increased. So with that, I would say that the amount of compute power and communication network within the vehicle, that definitely has seen a lot of change. On top of it, on a traditional way of vehicle design, now the electronics and the software part, that is also becoming more and more relevant. And I would say rather it's a challenge also for the automotive industry, specifically a traditional way of vehicle design versus the way things are changing. So how we are able to make things transform, actually that's itself is a challenge. And I would say that here plays a very important role that how we are able to evolve the traditional set of mindset, because let me tell you that the basic engineering never goes away. That basic engineering is the base of any automobile design. Because yes, because that still remains the same, because that we can never forget when we are talking about all these big names which you have just now spoken. I think the base remains the basic automobile, which still remains a very, very important thing. But on top of it, what we need is how we are able to make the hardware which is more efficient. Because as you see, if you have to take care of infotainment, if you have to take care of safety, if you have to take care of vehicle functionality, ADAS is a very important aspect of vehicle safety. That requires a lot of compute. So how that is integrated with the engine controller, the body controller, so how we are able to make the whole compute come together. Maybe today it's happening. It cannot happen maybe on a touch of a button that everything can come together. But how you are able to, if you don't do that, things will be more inefficient. So they have to come together and they have to communicate with each other. And as you rightly said, that software plays a very important role, because today on that basic engineering, a lot of software is required so that things are
Smooth and
yes. So we are able to make systems which are foolproof. So I think today a vehicle has hundreds and millions of coding lines which goes into it. So I think, and from here I would say, as the customers are evolving, as the regulation roadmaps will evolve, these things will happen. But I think this will be primarily driven out of what customer wants.
Mr. Mittal, I would like you to put your thoughts about digital transformation, because whereas his objective is, Mr. Raina has a different objective, has a different customer base. You also are a traditional player, but your customer requirement, your customer base is completely different. So how have you seen digital transformation, and what are the key challenges that you see right now?
So first of all, when we look at digital transformation, we have to see that it's a co-owner of a business transformation. That is how it has to be seen. Anything has to be led through a business transformation, be it in terms of the customer side, be it in terms of the functions that are involved in making it happen. So as Mr. Raina mentioned, everything is driven or evolved from a customer requirement. The customer is the end, right? 3-4 things which has happened in last 6 years, which has given that, I'll say, the push to the adoption. Number one is emission norms. First driver for it. The moment we moved from BS4 to BS6, electronics contribution started increasing in the vehicle. Now that means my vehicle is intelligent, ECUs are getting increased. Now that is why we are talking about these architectures like ECU architecture and a domain architecture, which is, you just use the term corporate or intelligent software-defined vehicle is the end. I don't know, maybe something like an end state we will look at, and then domain to and software-defined vehicle architecture we talk about, right? So somebody used to say that it's instead of software-defined vehicle, we should say it's a software-enabled vehicle. So we are enabling it, we are not defining the vehicle, because ultimately vehicle is still manufactured in the way it is to be designed with a core technology keeping in mind. You can't take away the regulation aspects, you can't take away the compliance aspect and the basic functioning of the vehicle. What you are going to add is the experience element of it, which is driven through the technology. Now that is how we see that, okay, that transformation aspects comes into picture. This involves a lot of technology aspects to be considered from a vehicle, lot of digital technology aspects to be considered, customer experience aspects to be considered. When you look at all these three together, then it's associated change management aspect. Because customer literacy also has to be coming into picture when we look at our segment of customers. The literacy level of a customer buying a passenger car or passenger vehicle versus a commercial vehicle is totally different. And the persona who is using that vehicle is having a different level of literacy versus the person who is having a car or a bike. So keeping all those in mind, these aspects are taken.
Interesting. Malbhai, we've heard two legacy OEMs tell us about their journey in the digital transformation so far. You're one of the youngest here, and being an OEM, how do you see, you only have EVs to address at the moment, and you've started quite young. So what is your view on the digital transformation? How do you see, because you don't have a legacy baggage with you?
I mean, we still come from an era where thoughts are still aligned to, your the V cycles don't really shorten themselves at all. So a few things I kind of wanted to put out there, because when we talk about software defined vehicles or AI defined vehicles, or we talk about AI use cases on vehicle, one thing, and I kind of echo what both of these gentlemen said, an update in software is equivalent to a recall in hardware. You're doing the exact same thing, you're changing something. But one has a very positive connotation, one has a very negative connotation, and end effect is exactly the same. If you're not careful with what you're deploying, you run the risk of systemic failure. And that is where, I mean, talking that, why is it easy for an individual to log on to Gemini or GPT and, type up an email or type up a WhatsApp? It's a low risk, low reward kind of transaction. But when we start putting, one, you move to domain controls, so now you have single point failures. And then you add in a layer of complex code, which I'm hoping everyone understands what they're putting on, but if you don't, it's compounding the problem of failure that you don't know when things might go wrong. And that's where it comes down to testing, 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 and testing. But now we are also using AI to run most of the testing cases. So it's suddenly moved from a specialist world to a generalist world today, where the ability to deploy is more to do with common sense and first principles engineering than a specialty skill in a tool or an application. So with this is kind of the basis on which we started our journey in kind of going towards the AIDV platform, which in simpler words is we had 7 ECUs running on a motorcycle. I think you guys must be in a much higher volume, but for us 7 was too much. We said let's bring it down to essentially one. Now you bring it down to one, hardware is still relatively easy. You know what compute, what processing goes, but now when the software layers get stacked on, where does safety go versus where does performance go, which precedence goes to the top, how do you do trade-offs, what happens, because everything is real time. I mean, even your ABS unit which triggers is real time competing with memory for something else. So those are the places where we had to go back to first principles. I mean, what is the purpose of that item? It wasn't like memory hai to ye kar do, wo hai to ye kar do. Now, for us as an organization, what we have seen is from 7 ECU functions, we became one function. Efficiency of people, conversation, speed, clarity, all of those things went up. Cost came down significantly. That's the biggest advantage from an OEM's perspective when you're talking about software-defined vehicles, when you're having that compute power coming in. But the complexity and your edge cases for failures have also compounded and gone, 1,000-fold more. So, as I said, hardware is the first thing that has to be protected, that has to be robust because it's recall. OTA still can be pushed. I mean, if the AI just doesn't navigate you on the fastest route and passes you through Gurgaon every time at 7 p.m., fine, that's a solvable problem. But if the brakes don't work, is a very different problem altogether.
True.
So, we are approaching this again from the first principles, solve the hardware, move on to the software, and the journey that smartphones have gone through, today you're really now feature differentiation. Everyone's reached the same degree of functionality is where we are seeing how human and machine interactions are going to be, especially on vehicles going forward. They're going to be minor differences, but they're probably going to run now or change at the same pace as your phones.
You brought in a very important point of hardware, but hardware is also something which has to be future ready. You have to know what hardware to adopt today, because that's where that becomes your base and you build on top of that. So it becomes extremely significant for next few years. I want to ask you, Gaurav, how do you decide on significance of hardware, and how do you approach procuring hardware for yourself?
So, in our scenario, to add on to what sir and Mr. Mohan has mentioned, I'll start a little bit with the software, like, because the hardware actually comes from like what software requirement, what features you are building. So for example, if you are building an ADAS, your requirement goes completely different versus like, if it's just a warning system from an instrument cluster perspective, or whether you're looking at a hardware from a motor controller or, for maybe a VCU. So the hardware requirement goes from what feature we are building, what component we are building. So I'll first touch upon the software part, like to add on to, I think maybe since we are also EV company and building it ground up from the EV, we have started adopting software and AI like much earlier in our overall development cycle. And all our vehicles have been connected to the cloud from like day zero. Like our first versions, which were launched like 6 years ago, they have been connected to the cloud. They have been pushing data. And ours is commercial vehicles, delivery vehicles, last mile, small size. So small commercial vehicles, three-wheeler in the beginning, and now we have for last 2 years also making four-wheelers as well. So the usage pattern has continuously helped us improve the product from both configuring the size of the battery for different markets, like because battery becomes a major cost. So if we see that the usage pattern in smaller cities, like let's say Jaipur versus Lucknow versus Delhi and Mumbai, where the travel distances that they need on a daily basis is, let's say, 120, 130 kilometers versus there the requirement is 60 to 70 kilometers. By having two configurations of the battery, we are able to control the price for that smaller market as well, smaller city as well. From a warranty perspective, performance perspective, what we realized was that different segments, because this is commercial, and commercial, sir would of course agree, commercial vehicles is probably one of the most abused vehicles within our country. So like, we get it tested with and release it with like maybe a 1 ton payload. You'll never know what that guy is actually going to load. So the amount of, resilience that you have to build within that product, that has actually come from data itself. Like we have been able to build our models that, okay, based on the, torque consumption, current consumption, what actually is he actually loading? And then from that segment as well, like a cargo, e-commerce cargo would have different kind of failure pattern versus someone who may be using it in the cement industry, or a third guy who may be driving it for delivering LPG cylinders. Like all three would do different kind of damages to my, overall mechanical structure. And so all those learnings has helped us from the perspective of how we, like sir said, like, a mechanical update is actually similar to like a recall. So it's like this has helped us sort of look at that how, because we can't change the customer. So it is his livelihood. If he's getting a work for like 1.5 tons for a vehicle which may be rated for 1 ton, he's not going to say no. His livelihood depends on that. So as an OEM, what we can do is we design the vehicle more and more resilient. We add additional checkpoints by looking at the pattern. So in our scenario, how we have sort of looked at digitizing the entire journey is that when we manufacture the vehicle, we have our internal sort of proprietary product where we start capturing the data. Because one of the apprehensions that we have seen within the mindset of a customer who may be sort of moving from an ICE vehicle to an EV is that, oh, how long is the battery going to last and how much it's going to cost. So that is like a barrier that we need to give comfort about. And then we also need to make sure that, it performs more than what we are actually promising. So the good thing with these connected vehicles is that, my battery with all the sensors, at cell level, I'm getting all the data. Same with my, other components of the powertrain. all of that sort of helps me that when we build the vehicle in the plant, like day zero when my vehicle is online, we sort of make like a digital twin. So which helps us that, okay, this is my baseline performance that we are looking at from the powertrain within, of course, like a certain variation, but we set that benchmark. And then we look at that, okay, when the vehicle is delivered, it's coming for service, how the usage pattern is impacting certain parts. And then we are able to use that input to, either improve at how the abuse is happening, what sort of protections to be built further. We use that for our, next product development cycle as well. Like, this has also helped us evolve from an perspective that the rate at which we are able to sort of make either minor or major changes in our products, because the data helps us that how the customer is using the vehicle, that helps us build different variations of the product. So a lot of the things from a hardware perspective, like if we are looking at ADAS, let's say in one of our next versions, so we of course look at that, like maybe in 6 months we'll only be adding limiting features, but how do we see that over the next 3 years, what are the features that we are going to add on? So that of course sort of defines, coming back to the original question, the hardware requirements. And same goes for like not just hardware from an electronics perspective, but from a mechanical perspective as well, that if we look at the e-commerce industry, looking at Delhi to Chandigarh routes, then we'll think about like, okay, my fast charger has to perform this way, because we have to price it that with all the commercials, because ultimately these are commercial vehicles used to run a business. So if they are not giving ROI, no one is going to just buy them for the sake of it. So that entire commercial calculations which comes from the usage of the vehicle pattern as well, goes all of it together. So it's all connected, and there of course there is a service software as well, which helps us connect that how do you plug in the different kind of additional checks, because we know, okay, this particular guy is using it for the LPG cylinder use case. We need to, add those checks within our system itself. So I think sir will have his own points as well. But yeah, commercial vehicle industry is for them the business has to run, and the vehicles are definitely abused. So a lot of the requirements actually comes from what segment we are looking at.
In case usage.
Usage,
Ajay,
yeah.
I want to ask you that he has talked a lot about how usage has impacted their development, but I want to ask you, in organizations which are consumer oriented, all of you all are consumer oriented, but it's okay to give OTA, as he very rightly pointed out, but your hardware has to be strong enough to have those large data coming in. Like, for example, sometimes it has happened with iPhone, with Apple, which is like one of the best organization in software and hardware. They have given updates, and those updates have not been really well received, and they have had bugs. But when the product is on the road, it cannot have those bugs. So how are you safeguarding? How significant is the role of hardware for you to be able to plan for future?
I think he rightly said, if hardware, that testing is very, very important for any kind of a development. And it's, before moving to testing, he rightly said what kind of a segment you are going to, like that, which product you are manufacturing. If you are manufacturing like that, Sandeep San has told about car, commercial vehicle, is a mini commercial vehicle. So all customer are different. So Mohanji customer is different, my customer is different. So what segment you are going to manufacture, what kind of a product. So based on that, understanding what kind of a feature, what kind of a technology integration, what kind of a hardware and software you need to manufacture. And in that, all the regulation upgrade, futuristic and feature requirements, so need to be considered, and based on there are testing parameters of each thing. But all things with AI you can take help, but those are the subject expert. AI only teach you the sequence and other thing, but not only mans are integrating those things.
Yeah.
So those things are very important, and what we are doing, we are testing each and every parameter before putting it on the hardware part. So all the features, whatever feature is required, whatever futuristic requirement or OTA is required, because OTA is just sending OTA is, I can say, that is diagnosis. So only major thing is that what vehicle is doing, that is diagnostic, what kind of a problem is there, what kind of a error is there, and through OTA we are solving those problems, or we are pushing software to give commands, and vehicle
Solve
is
the problems.
solving the problem. So those things, I think, but the major thing is that we have to work on end to end. It is not about, we have to work on the customer side also, whatever we are developing, customer side also, manufacturing side also, product side also, and sourcing side, sourcing and supply chain. So it is very important to cover all the cycles, all the aspects for digitalization, for AI integration, because if you work on a one side and satisfy the customer, so that will not solve the problem of the company. So that is very important, I think.
Dhirendra ji,
Yeah.
one of the very important aspects that Gaurav brought in was data.
Yeah.
Right now, every technology that I have spoken to or heard from an OEM is either requires data or is an outcome of data.
Yeah.
Are the OEMs collecting the real data? Well, Sandeep San in the beginning said that millions of codes today run a vehicle, right?
Yeah.
I think we're generating more data. Our vehicle is now generating much more data points.
Yeah.
Are they being really put into practice for better products, or are OEMs, because you work with a lot of OEMs,
Yeah.
or are OEMs missing the big picture when it comes to data?
No, not really actually. So definitely, a lot of telemetry data is coming in, and I think every OEM is analyzing those data, and as Gaurav rightly said, understanding, analyzing the data for the improvement of the products from a quality, reliability, robustness, and even from the cost perspective. I think that is all happening definitely. So coming back to your original question of digital transformation, how do we see, as everybody here is a product OEMs, I come from a providing the software or a digital backbone for them to really manage all of that everybody is talking about here, right? So definitely there is a huge transformation that we have seen in the last 5 years, especially post-COVID, because people have realized that they have to be digitally enabled, because COVID really disrupted, right? We have to really shift computers to home and installing licenses to continue to work, right? So people have realized that how important it is to be connected, how important it is to be always online. You don't have to depend on the infrastructure or in the office. So definitely there is an improvement. So I'll talk about 3 things how the transformation is changing. One is from a hardware perspective, right? So I think most of the OEMs already have the foundation, product data foundation, in terms of their engineering data, telemetry data coming from the field. I think that foundation is getting well established. But I would still see there is an improvement that, even from a hardware perspective, when you see a different functions, still people are working in silos. There is a good improvement to bring everybody on a common platform and break that silos and enable a common product development platform to everybody come together and, do the day-to-day task. So to enable the digital thread across, because still digitally, the transformation is happening in pockets, like good transformation engineering on the service side, the manufacturing side, the quality side. It's all happening everywhere. So individually, it's really improving. But I think the idea is to really bring everybody together. I think there is a good scope I can see. But I see a real transformation that is happening on the software side, especially with all of that everybody spoke about, software-driven innovation. And I think this is a fantastic example that he gave. Software failure is equal to a vehicle recall. I would never forget the sentence, what he said. So that means managing the software, entire life cycle of the software, and establishing the traceability becomes extremely important. And for that, you need a proper digital backbone to do that, right? Without a digital platform, it becomes very difficult. I think that is the real transformation is happening. Like, for example, a lot of organizations used to do this document-based systems engineering, for example. System engineering is happening where the holistic view of the entire vehicle is understood at the beginning before you go to the development. But now you need a platform to really manage that, right? So that is one thing that we see, because you need to have a traceability and all of that kind of things.
So second one is the hardware software integration on a common platform. That is more important because there are no more silos now. Most of the time we have always seen software working in a different way, hardware working in a different way, right? But coming together on a common digital platform and have that integrated view of the electrical, electronics, mechanical, software, everything put together, right, in a vehicular platform. That is very important. So that we call more as an ALM. PLM is more from a hardware perspective, which is okay, which is well established, and of course, as I said, there is some improvement. But ALM is where, like, ALM is a PLM for a software data, while PLM is a PLM for a mechanical data, right? So now these two have to come together and have that integrated platform. That is where I see a real transformation that is happening, where a lot of organizations are really re-architecting their digital platform to have this common integrated hardware and software development.